Hi there, and welcome to this tutorial where we are going to have a look at how we can instance a dense geometry file and offsetting the playback of this animated geometry and maintain a steady 60 FPS. So without further ado, let's get started. The problem with rendering animated dense geometry is maintaining a steady 60 FPS. I've downloaded this model from mixamo.com. It's in an FBX format, so if we hop in, we'll see that there are a lot of empties representing the bone structure of the animation. The mesh itself is split into several parts, and in sub level the model is steady. And if you have a look at the information, vertice count is quite a lot, and it adds up quite a lot if we add all these geometries together. So if we're going to render this one out, we use a render, camera, we need some sort of lighting. Let's see. Switch render flag on. It's quite up close, so zoom out a bit. Looking at the back, if we change the pivot, minus the translation, you always keep the model in the center, so you can rotate it around it. So we might use another light, position it at a different spot. Geometry viewer, let's see. Somewhere up here. Well, this is okay for now. Well, you see that with one model, it's keeping 60 FPS quite well. But what if we like to have more copies of this model? So you probably have heard a lot about instancing. But where's the instancing tab on this FBX container? Well, there isn't. So what we need to do in order to get more copies is copy this FBX. So let's copy one. It froze the frame for a while, and you see that it's already starting to drop. So to keep these things optimized, I can close this one. So now you see that it's back at 60 again. Close this one as well. We'll leave the render on. Would like to have this one at a different position. So translate somewhere up here. Well, I would like to have another copy. Well, so it froze the frame again. So you see that now it's going to drop slightly. Let's see, offset this one a little bit up here. Okay, last copy. But you see that now it's going to drop quite drastically, and this is with only 4 copies. So, and again, this is such a cumbersome way of copying or working around the whole instancing way of copying geometry, which is way more optimized. So I'm going to have to find a different solution in order to instance these dense geometries and maintain the playback offset. We're going to do that with an Alembic file. What I'm going to do is I'm going to import the FBX into Blender and export it back as an Alembic, because Mixamo.com doesn't have an option for downloading Alembic straight away, so we have to convert it manually. So I'm going to fire up Blender. Okay, we're in Blender now. I'm going to import the FBX into Blender. Import. So there it is. There are different objects, so I'm going to merge them first. Select one, shift select the other one, Ctrl J for joining. If you select the armature, you can see how many frames the animation lasts. It's 17 frames. So put that one in here and 17. So if you play back this, it's going to loop. Okay. We'll select it again and the armature file, export, Alembic. Leave everything at default. Choose a location and hit export. So we're back in Touchdesigner. Going to look for the Alembic, which I've just exported from Blender. Just drag it in. And you see that compared to the FBX, this is all it is. It's just one sub, all neat and tidy, packed in one operator. If you look at the parameters, you have this time slider. If you set this one to frames and scrub through it, you can see how many frames the animation actually lasts. If you remember that the frames in Blender were 17 frames, so the animation lasts 70 frames, but we exported the animation at 30 FPS, and since we're going to play back this one at 30 or 60 FPS, it's basically twice the amount of frames that we needed. So the animation is going to last probably somewhere around 34 frames. Yeah, that's correct. At 34 it stops. So it was 17 multiplied by 2 is 34. So what you're already noticing is that while I'm scrubbing through this time slider, that the frames is actually dropping quite a lot. So if I'm going to use an LFO, let's see, set this one to ramp, adjust the range from 1 to 34, close it with a null. And if you drag this one in, you see that it's even dropping more frames than with the FBX example. So how is this ever going to give me more optimized results than with the FBX? But we're only going to use this time slider once, because we're going to record all the vertices locations into a texture. I'm going to stop this time for now. Delete this one. And we'll start with this fresh Alembic. Close it with a null. And I'm going to convert this to chop data. Let's see, we're going to use the TX point positions. So let's see, 31,000 points, 31,000 samples. So that's correct. Close it with a null again. And then we're going to convert this chop data into tops, so a texture. And so this is basically 31,000 pixels wide. So that's not very useful. We'll set this one to RGB. So now it's also 1 pixel high. It's an option to record this, but if you're on a non-commercial license, your width is going to clamp at 1280, so it's not very useful. You're going to miss a lot of data. So if you set this one to, let's see, fit to square, it's going to reorder or reorganize all the pixels into a square sized texture, so that's quite convenient. I'm not sure when they added this function. It's not very long ago, but so if you can't find this fit to square option, then you're probably on a quite older build, so sorry about that. Let's see, close this one with a null. So now we have this alembic SOP represented into a texture. So the X values are transformed into red values, the R, the Y into the green, the G, and the Z into the blue channel, RGB. And that's basically a vect3 value, but that's something I'm going to explain a bit later. So as we're going to animate this one, you see that the texture is also changing width. So you could record this animation into a movie file, and then you basically have a movie clip which represents the animation of this alembic SOP. But there's a more convenient way in recording this, and that's by using a texture 3D top. And what this texture 3D top does, it's recording this texture over an amount of cached size. So in this example, it's 32. Well, the animation lasts 34. So we're going to fill in 34 in here. And if we connect this one, you see that it's already recording 34 frames. But the downside is that it's only recording this frozen pose. So it's not very useful at this moment. So we're somehow need to animate this alembic and also let this one record frame by frame the displacement of these points. First thing you need to do is we need to switch this active button off, and then this first grayed out section is going to light up. If I reset this texture, it becomes empty. Switch on active, it's going to record again. So start with a clean one. And if I, let's say I would like to change the index 6 of this cache sequence, I'm just going to put this one at 6, hit pulse, and there it is. Switch this one to a different position, pulse. So I can change this time to, let's say, the first frame. I would like to have this one at the first position. So there it is. So you see you can record this entire sequence into a texture, 3D top. So what we need to do, we need to synchronize this time with this replace index. Okay, so let's recap. We have an alembic SOP which lasts 34 frames. So we need something incrementing up into 34 frames. And we can use a speed job for that. So speed job. It needs an input. Let's see, constant. If you leave it at 0, it's not going to play back. As soon as you put a value in here, let's say 1, it's going to start. Let's see. I would like to have this one limited. So clamp at 34 frames. Let's see. I would also like to have this one in integers. So I can use a quantize. I believe it's in the limit. Quantize value. Set this one to floor. Value step 1. Yeah. So now you see that it's incrementing in steps of 1. If you reset this, I think I'm going to play back it a little bit faster. Set it to 30. Okay. We'll leave it as is. So, okay. The limit is going to be driven by the null for. And let's see the replace index as well. Okay. So if we are resetting this one, okay, this is going to play back. So now we have to press this pulse button at the exact same moment this null value is stepping 1 up. And we can use a job execute for that. Oh, wrong one. Job execute. Let's see. See that it's quite intensely dropping frames, and that's because this null is cooking constantly. So if we put this one to selective, okay, this alembic won't cook anymore. So, and since this one is quite heavy, it's going to drop frames. So put this null to selective. Let's see. This job execute is going to execute when this null 4 changes. So put null 4 in here. We'll have a look at all channels, just one, so it doesn't really matter. On value change, I would like to pulse this replace single button. So let's see, texture 3D1 op text 3D1 dot bar dot replace index pulse dot pulse. So if you're not sure how this is called, just open up this parameter, hover over it. If you're not sure how this, let's see, yeah, hover over the parameter itself, replace single pulse, replace index pulse, so it has to be single pulse. Okay. So it might already work. So if we reset this one, so it sort of works, but not quite yet. So you see that it's missing these spots. So let's try again. pulse. No, and it's also going quite fast. So the thing is that this recording sequence is trying to run at 60 FPS. So it's forcing itself into a way faster playback speed than this recording can keep up. So if we switch this real-time flag off, we hit pulse again, you see that it now sort of works. This is also quite convenient. You see that the texture depth is 34 cached frames. So that seems to work. This is the basic setup how to record an alembic into a texture. What's a little bit inconvenient is that you have to switch on the real time again. If you would like to record it, you have to switch it off. So it would be nice if we have some kind of automated system where we can just push one button and it records, and you can push another button to clear it. So it might be convenient if we can somehow convert this to a tox. So I'm going to select all of this, collapse selected. I'm going to call this one Alembic Recorder. So a couple of things. I'm going to make a customize component. So we're going to import customize parameters. First, give it a name, call it parameters, add page. So we have an empty page. Okay, a couple of things we need. The first thing is the Alembic file itself. So Alembic file. And that's going to be a file in, I guess, yeah. Okay. Second one we need is the amount of frames the animation lasts. So num frames, and that's going to be an integer because it's round number, so it doesn't have any decimals, so integer. And then we need a record button. So record, and we'll use the pulse. And it's also convenient to have some kind of start over button, so a clear might be convenient, a pulse as well. We'll just leave it here for now, okay. So let's see, if you go to the parameter chop, so now you see that the customized parameters are in chop shape. Close it with a null. I'm going to split my window to have a look at this customized component. Okay, first things first. Number of frames, let's see, 34. So it's going to show up here as well. And where did we need this number? In here, the maximum of the speed chop. Okay. Any spots? Yes, the replace index. Let's see, no, it's not a replace. The cache size, yeah. In there. Let's see. Anything else? No, I think that's already working. Okay. This Alembic file, we'll have a look at the parent. Par Alembic big file, I believe. Set it to expression. Okay, again, parent bar.lembic file. Use capital because the customized parameters are always starts with a capital. So there's nothing in it, so we have to load this lembic file in here. So there it is, back again. This pulse button, which is showing up here already, needs to trigger a couple of things. I'm going to write a customized script. I'm just going to use a text dat for that. First things first, the speed job needs to be reset, so it has to start at 0. But if I press the reset button, it's going to play back immediately. So I have to put this constant to 0 as well. So two things. The speed job, speed 1, needs to be reset. So up speed 1 bar reset pulse, I believe it's a reset pulse. Reset, yes, reset pulse, and to actually pulse it, what we also can do is just flip this reset knob. So just reset is 1. Okay. And the other thing was the constant needs to be 0. So value 0 is 0. We call this script start. But the weird thing is that since it's a start script, it actually has to start playing when this script is executed. So we have to invert this. So the reset value is going to be 0. So the speed job is going to be charged. And if we fill in this 30 value again, it's going to walk. So if we run the script, we get an error. So I've probably made a typo somewhere. Let's see. No attribute bar. Speed 1, constant 1. So again, right mouse button, run script. You see there it's going. And there it stops. So the start script is working. But I would like to run this start script when I press this pulse button. So what I can do is I can use a parameter execute. So this one is going to look at the customized parameters in this base container, the parent of this network. So let's see, I'm going to look at the onPulse parameter. So first we have to look at the right pulse button. So if bar.name equals record, then op start, so this is the start script that run. Okay. So now if we switch this back on and this back to 0. Let's see the operator where it's looking at is the parent. Ctrl M to put it in expression. We look at all the parameters, so put an asterisk in there. On pulse is on. So now if we push this pulse button, you see that it's running. Okay, so that one is working. What's a bit inconvenient is that when testing this, I have to flip this reset button and change the constant value. So I also would like to have a script which clears out everything. So a new text that, call this one reset. And let's see, I can basically copy this in here. This one to 1, this one to 0. So I'm going to fill in another if statement. If par.name equals, what was it called? Clear op reset run. Okay. So now if we hit this clear pulse, you see that it clears out. Record. There it goes. You see that this texture 3D is changing along, so we somehow need to reset this one as well. So op text 3D reset pulse. Let's test it. Get an error. Let's see. Is it actually reset pulse? Yeah. No attribute reset pulse. Text 3D. I might have a typo. 3D1. Okay. Try again. Pulse. No. Still an error. No attribute reset pulse. Text 3D1 dot, forgot the par. Okay, another try. Yeah, now it's working. See, so this one blanks out. Record. There it goes. So again, this texture 3D top recording has to catch up with the real-time frame rate of 60 FPS, and that's way too fast. So we have to switch this one to real-time off while recording. So what we can do is, if we pulse on record, we can switch this one to non-real-time mode, and the function for that is project real-time, capital T, let's see, is 0. And I believe that if we switch on record, yeah, you see that it's moved to non-real-time mode. So, okay, that's convenient. And what we would like to have is that it's going to switch back on if this 34 number frames is reached, so that the recording is basically done. So as soon as the recording is done, it has to switch to real time again. So we can have a look at this value. Let this job execute look at this value. And let's see. We somehow can fill in an if statement here as well. If value equals, I was tempted to fill in 34, but then you're going to make it hard-coded because not every Alembic file has an animation of 34 frames, so it somehow has to look at this dynamic value. So op, I'm going to change this one to parameters. So now I get all these errors. I had to do this in the first place. So parameters. Let's see, where did I put it? Parameters. Op. Parameters. Num frames equals. Now let's see if val. Oh no, this is already working. Yeah. Let's see, we can run a stop script, so I can make a different text that. So I'm just going to run the stop script, but we have to build that one first. So op stop run. Okay. Another text that stop. And the first thing we're going to stop, or probably the only thing, is we're going to switch that real-time flag back on. So project dot real-time capital T is 1. So let's see if everything is working. Clear. Get this error. Let's see. Oh. No, I changed it. Well, we'll just see what happens. Clear. Recorded. You see that it flips back on. So let's see. Try again. I'm gonna make this a bit smaller. Clear. You see that when we're clearing this one out, see, record it, misses one position. Now it's recorded it, so we somehow need to adjust this reset value. Let's see if we put this one to -1, and this one as well. Clear. Record. Yeah, now you see that it's not missing the first one. Clear. So this is still showing up, but I don't think it will give much problems further up, so I'll just leave it for now. Okay, so now that we have recorded our Alembic into a texture file, we can dive into GLSL and see how we can set up the vertex shader in order to replay this Alembic file in a more optimized way and instance this model and keep a steady 60 FPS frame rate. Please click further to part 2 where we'll start into GLSL.